Hello, welcome back to Statistics and Mathematics YouTube channel. Today I'm going to solve examples on Poisson distribution. Please, if you haven't subscribed to my channel, kindly subscribe, like and share so that this video will get to your friends for them to also watch. So question 1 says, an automobile manufacturer is concerned about a fault in the braking mechanism. The number of cars per year that will experience the fault is a Poisson rate. It means 6. Okay, yes. So here we have seen that our lambda, right, our lambda, or we can represent this one to be lambda or mu. Okay, you can use it interchangeably. Okay, so when we come here, we are getting our lambda to be equal to 6, or what we use in our discussion earlier was what? Mu. Or we can use our mu to be what? 6. Okay, that is what the expectation. So he said we should find the probability that at most 3 cars experience the fault in a year. So here we are going to calculate for probability that our x is less than or equal to what? 3. Now our x is less than or equal to 3 will be what? Already we have our lambda or mu. Okay, so here our probability that our x is equal to that is equal to mu is equal to mu raised to the power x, which is 6 raised to the power x e raised to the power negative 6, all divided by x factorial. That's what we have. And then we have probability that our x is less than or equal to 3. Probability that our x is less than or equal to 3 is equal to probability that our x is equal to 0 plus probability that our x is equal to 1 plus probability that our x is equal to 2 plus probability that our x is equal to what? 3. And this one can be written in what? In the form of what? Summation. That is summing from our x summing from 0 to what? 3 of what? This one. So we are just going to calculate for probability that our x is equal to 0. So probability that our x is equal to 0 is e raised to the power negative 6, of which we are going to get this one. Probability that our x is equal to 1 is 6 e raised to the power negative 6. Probability that our x is equal to 2 is 6 raised to the power 2 times e raised to the power negative 6 divided by 2 factorial. Probability that our x is equal to 3 is 6 raised to the power 3 times e raised to the power negative 6 divided by 3 factorial, of which we have this to be our answer. So for us to get probability that our x is less than 3, we are going to sum all the probabilities we have here, and then we are going to have 0.15105 to be our final answer. Okay, yeah, so here we are just going to substitute 0 to this, 1 to this, 2 to this to get what the probability is. Okay, so don't just get yourself confused. So the second question says, find the probability that more than 1 car experienced the fault in 6 months. Okay, so you could see that the what they give us here was what? In what? Years, right? Said the number of car per year that will experience the fault is Poisson rate what? A mean of what? 6. So it means that we are giving the mean to be what? We are giving the mean to be what? 6, right? By here, in 1 year, by here we are having 6 months. So for us to be able to calculate for that one, we have to divide our mean by our 2. Okay, of which we are going to get 3. So because here was what? In 6 months. Okay, so we cannot work with what? The mean of what? 1 year, which is 6. So for us to be able to do that, we have to divide it by 2 to get what? 3. Okay, yes. So we have our mean to be what? That. And then the question says, we should find the probability that more than 1 car experience the fault. So if more than 1 car, I mean that probability that our x is greater than 1, which can be written as 1 minus probability that our x is less than or equal to 1. Okay, of which you are going to get this one. So here already we have our this one to be equal to 6 raised to the power x e raised to the power negative 6 all over 6 factorial. So you are just going to substitute 0 and 1, of which you are going to get this one. And then when you point it on the calculator, you are getting our final answer to what? 0.800852. And then we have this one to be what? Expected number of cars in 2 years. So this one is within 2 years. The first one that we have, it was in 1 year. So for 2 years, you have to just multiply our lambda or mu by our 2 to get what? 12. Okay, yes. Our next question says that the number of customers arriving per hour at a serving facility is Poisson rate, a mean of what? 7. So here we have been giving our mean to be what? 7. Okay, please, if you see the lambda, you don't get confused. So right, the PMF can be written in 2 forms. Either we can use lambda or what? Mu. Okay, so for this slide I choose to use lambda, but usually you see I keep on using mu. Okay, so that you not get confused. Okay, yes. So here our mean was given to us to be 7. They said find the probability that more than 10 customers arrive in 2 hours. Okay, yes. So here it was given, the mean was given to us in what? 1 hour. Okay, so you have for 2 hours, you have to multiply it by 2 to get what? 14. That's the reason why you see 14 here. Okay, and then we said we should find the probability that more than 10 customers arrive in 2 hours. So we are going to get probability of x is greater than 10, which is equal to 1 minus the probability that our x is less than or equal to 10. So we are going to get 1 minus summation of x, which is moving from 0 to 10, of what? The p mf of that. And then for this one, once you point this on the calculator, right, we are going to get our answer to be what? We are going to get our answer to be what? 0.825. So punch all of this one on the calculator to get your result. And then B, we are saying that the mean number of arrivals in 2 hours. So if you want the mean number of arrivals in 2 hours, you are just going to multiply it by 2, the mean, because that mean was what? 7, which is in 1 year, by 2 will give us that is 2 hours. This is 2 hours. So the first one was what? 1 hour. We are just going to multiply it by 2 to get what? The mean for what? 2 hours. This is what? 14. Yes. That is that. So for question 3, we are saying that during a war, the probability of hitting a target is 0.001 per shot, right? If 500 shots are fixed, right, find the required probabilities, right? Find the required probabilities. Okay, so here it said that you find probability that exactly 4 shots hits the target. Okay, but you could see that here our p is very small. Yes, we have our p to be what? 0.01, and then our n is also very large, which is equal to 500. Which is equal to 500. So that means that we cannot use binomial distribution to solve this particular question. We have to use this technically a binomial distribution question. So we have to use Poisson to approximate the binomial. Okay, so here we have to calculate for our lambda, which is the mean, and then that lambda 2 is same as what? Which is equal to the mean, which is equal to what? The expectation, which will give us what? N times what? P. Of it, that one will give us 0.5. So our mean here is 0.5. So once we have our mean, our probability mass will give us what? 0.5 raised to the power x e raised to the power negative 0.5 divided by our x factorial. And then we have been asked here that we should calculate for probability that our y is equal to 4. That is exactly 4. We are just going to substitute wherever we see x to be 4, right? And once we do that, we are going to get our answer to be 0.0015. And then the question says probability that at least 2 shots hit the target. So if at least 2 shots hit the target, it can be expressed as probability that y is greater than or equal to 2, which is equal to 1 minus probability that our y is less than or equal to 1. Then we have this one, and our answer is 1 minus 1.5 e raised to the power 0.5, and we are having 0.0902 to be our answer. Okay, and question 4 says a random variable x has Poisson distribution with mean mu, giving probability of x to be equal to 2, which is equal to 0.6 times p bracket to p x is equal to 1. Said we should find our mu. Okay, just express this one. So you are going to express this one. Already we know our PMF, but we know that our x is equal to 2, and I have been asked to calculate for what? Our mean. So that means that here will be mu raised to the power 2. Our x is being given to us e raised to the power negative mu all divided by 2 factorial, which is equal to 0.6 mu raised to the power 1 e raised to the power negative mu 1 factorial. That's how we are going to express it. Okay, yes. And then we can see clearly here that this mu here can cancel this mu here 1, and this one can also cancel this one. So we have mu divided by 2, which is equal to 0.6. Okay, yes. And then we are going to get mu is equal to 0.6 times what? 2. 0.6 times what? 2, of which we are going to get our answer to be 1.2 to be what? Our mean. Once we have our mean, we can calculate for the probabilities, and it said we should find the probability that our x is greater than 1. Probability that our x is greater than or equal to 1 can be written as probability that can be written as 1 minus probability that our x is equal to 0, of which our final answer for that will be 0.6988 for that one. Okay, and then question 5 says a random variable x has Poisson distribution with a mean mu, given that this is that. So for that one, we have already I've walked you through one question of that. Okay, so I'll not waste much time finding the mu here, and then here we'll go straight to the mu to do at 0.8, and then we solve this question. Once you solve it, this is how you can express this, and then our final answer there to be would do at 0.191208 to be our final answer. And then question 6 says that a random variable x has Poisson distribution, and then our probability that our x equal to 0 is equal to 0.05. So we should calculate for the expectation. Okay, so here we already know that our PMF is e raised to the power negative mu mu raised to the power x all divided by x factorial, which is giving us e raised to the power negative mu times mu raised to the power 0 all divided by 0 factorial, which is equal to 0.05. So you see I use mu here, but the solution use what? Lambda. Okay, so please don't get yourself confused. You can use them interchangeably. Okay, so let's focus on what I have here, and then this will be e raised to the power that is equal to that. The only thing we can use to get our lambda is what? To just multiply through by our ln. Once you multiply through by ln of what exponential function will give us the exponent. This is negative lambda of which is equal to ln of 0.05, and then we are getting that our answer of the mean to be at 2.9957. That is what we are having here. Okay, that is what we are having here. Yes, so the last question I have here will be on the characteristic function of the random variable. It says a random variable x has a characteristic function which is equal to e raised to the power 2 bracket open e raised to the power I times t minus 1. Okay, and we have been asked to find the probability that our x is equal to 0. So here we have to first define the moment generating function, right, which distribution follows, and we can see clearly that this one follows the characteristic function, which distribution it follows, and we can determine that for this characteristic function it follows what? Poisson distribution, where our lambda is equal to 2. Okay, our lambda here is equal to 2 because we are going to compare to what? E raised to the power lambda bracket open e I t minus 1, of which our lambda here is equal to 2. Okay, so here our PMF will be equal to mu raised to the power 2 e raised to the power negative mu all divided by what? Mu is equal to 2 raised to the power x. Here will be 2 x factorial. We have been asked that we should find the probability that our x is equal to 0. So here this is x. So we are going to get 2 raised to the power 0 e raised to the power negative 2 all raised to the power 0 factorial, and we are going to get our answer to be e raised to the power 2. E raised to the power 2, our final answer will be this, and probably that our x is greater than or equal to 1. We have this expression, and our final answer will be what? 0.864665. So this is Statistics and Mathematics YouTube channel. If you haven't subscribed, kindly subscribe, like and share so that this video will get to your friends for them to also watch. Bye, have a lovely